All right, we sent our edge-to-edge silicon carbide monolithic up to Energetic Test Labs in Arizona, and they sent it back nicely packaged with a test plan sticker. This is nice because it keeps everything together and lets us evaluate what happened during the test. So the first thing that I see is it's contained, and I can see through the package that we've got numerous shots in here, and all of those shots protected the strike face. So we'll peel this apart and have a look. First thing I see is that the shots that went in did not destroy the strike face of the ceramic, so you don't have a lot of ceramic fragmentation coming back out of the strike face once it's shot. This ceramic particle layer is just there because of the damage to the plate itself and shifting around during shipping. But you can see that the strike face cover, the crack arresting layer, did its job because you don't have a lot of open, ripped areas of fabric in the cover, and everything is nice and clean with just the projectile entry point in the strike face. Looking at the plate, we had a very good result. We had shot 1 here. That's the resultant BFD. Very little obvious back face deformation. And then we had shot 2 right here, kind of in the lower right-hand corner. And that was the back face deformation there. Very little BFD. Then we had shot 3, which is kind of over in this corner here. And you can't even see the back face deformation in the plate itself. You can see it in the energy in the test report. Shot 4 was over here, and this is the first shot that actually exceeded the 44 millimeter maximum with the NIJ, exceeded it slightly here. This cracking you get is the result of the bending and cracking of the trauma reducer layer. Shot 5 went through right there, and this is shot 5 down in between these two, 2 and 4. So shot 5 did go through, but this plate resisted the penetration of 4 .30 caliber M2 AP rounds. Very nice result, and it looks like our crack arresting layer with the monolithic plate combined with the adhesives and the trauma reducing layer is enough to improve the performance of a monolithic. But be aware that most manufacturers do not do these things. They do not apply crack arresting technology, and they do not apply trauma reduction layers, so you will not get the same performance from other monolithic plates. But let's take this thing apart and have a look. All right, so you guys that know work with armor, you know that silicon carbide is a lot sharper. The pieces are a lot sharper. It's a little bit more brittle than aluminum oxide, so you got to be careful with this silicon carbide and you're tearing the plates apart. But you can see the various layers in the plate, just removing the side fabric, and you can see that there's a trauma reducing layer. You've got polyethylene, you've got silicon carbide plate, and then you have the crack arresting layer on top. This is what a well-designed plate looks like, folks, especially on a monolithic. You've got to be very careful to protect the ceramic strike face with something that does not blow out and that will disperse the ballistic energy back through the adhesive layer instead of out of the strike face of the plate. So this is very good performance on a plate that just took 5 rounds of .30 caliber armor piercing. Okay, so here is the crack arresting layer with the quarter cover removed. And so this is what you would see underneath the actual cover. This cover was taken off, and this is what you have. So you can see how the entry points for the projectiles are protected, and it helps to protect that solid ceramic strike face here. Okay, so keep in mind we shot this to failure, so we did have a very nice back face deformation in here, and the back face deformation is really not all that noticeable. I think we came in the low 30s, which is not bad for a silicon carbide plate, but the obvious advantage is with the trauma reducing layer that we'll show you in just a minute. But we had a really good result back here. Of course, this plate was shot until it failed, and that test report will be followed on right after this video. Now I'm going to change the camera angle and see if I can pull this cover off of here. It's obviously the ceramic is destroyed in here, so it's difficult to pull this off without absolutely destroying the remaining ceramic. So you can see the effectiveness of the adhesives in here. This is the composite cover. This is what's hanging on in here. All this fiber you see in here is the result of a good adhesive still grabbing onto that silicon carbide ceramic. That silicon carbide's a little bit different than aluminum in terms of the stickability of the adhesive properties, and so our adhesives will work with the aluminum oxide, the alumina, and the silicon carbide. As you can see here, it's extremely good adhesion. But as you begin to pull this apart, you can also see the effect of 5 rounds of 30 caliber M2 AP going through a ceramic armor plate. So that's what's left. You've got a few chunks left, but not much. You've got a piece up here. Everything else is pretty much dust. And it was a very good performance given this reaction. It was extremely good performance to be able to stop 5 or 4 of those 5 armor piercing rounds with a monolithic plate with this type of performance. It's absolutely impressive. You can see how good the ceramic is, the adhesion to the ceramic is here. You can see light, you can see daylight through there. That means that crack arresting layer works. And you see the limited amount of area right here that the strike face was allowed to get damaged by that ballistic energy. So it trapped that energy and dispersed it back through the adhesive layer. And this type of fiber and the elongation of the material itself allowed that energy to be absorbed. And here is your back plate. Let's clean off the ceramic. Don't really want to breathe that stuff, believe me. So let's take a look at the performance of the back plate. This shows you how effective our trauma reducers are at reducing back face deformation and trauma in general. You physically can't see very much back face deformation back here at all. And this is impressive for a lightweight silicon carbide edge to edge monolithic.